Another L'Hopital's example. Say x is going to infinity and you have x cubed over e to the x. What is that thinking about? Well, as x goes to infinity, x cubed goes to infinity even faster, and as x goes to infinity, e to the x goes to infinity. So we have infinity over infinity. We may use L'Hopital's rule, and we say, what is the derivative of x cubed? Why, it's 3x squared. What is the derivative of e to the x? It's just e to the x. You say, well, that's also going to infinity over infinity. So you can use L'Hopital's rule again. This is going to the limit, this is the same as the limit as x goes to infinity of 6x over e to the x, which is also going to infinity over infinity. But if we use L'Hopital's rule one last time, we see that the numerator is the same as the derivative of the top 6 over the derivative of the bottom e to the x, which is thinking about 6 over infinity. You can't divide 6 by infinity. 6 divided by infinity is not a real number. You can't divide by it, but you can take the limit of something going to a fixed number over something going to infinity, and that gives you 0. So if you are going to write something like 6 over infinity on a piece of paper, please put it in a thought bubble. Please make it clear that you know that infinity is not a number that you can divide by, but that you can think about it. Anyway, so you can sometimes have to use L'Hopital's rule several times in a row. So, yeah. And this also tells us, this is a great example of no matter what power this was, if this was x to the 50th power, we'd have to do it 50 times, but eventually it will be ground down to some sort of big constant while the e to the x does not falter at all. That tells us that in some sense, e to the x is always more powerful than any polynomial. This is called, there's the big thing in mathematics and computer science called the difference between exponential growth and polynomial growth. Exponential growth is things that grow as fast as exponents, like e to the x power, or 4 to the x power, or something like that. Polynomial growth is something like x cubed, or x squared, or something like that. And exponential growth is so much bigger in the long run. Now, you plug in 2 cubed is 8, e squared is less than 8 because e is less than 3. So for small numbers, x cubed could be bigger. For even medium-sized numbers, x to the millionth power is bigger than e to the x. But in the long run, when you plug in larger and larger numbers as you go to infinity, the e to the x is more powerful than any polynomial.